Hello, everybody. This is Yonghwan Kim, CEO of Smart Radar System. Today, I'd like to talk about 4D AI radar as a cornerstone to smart city. Let's see the innovation happening in Siheung with the smart radar. Recently, there was a big news in the mobility industry regarding the collaboration between Mando and the smart radar system in developing the ultra-high resolution 4D image radar. The 4D image radar is an essential sensor in developing the level 4 autonomous driving. And then as a result of that, the Mando stock rose 3 days in a row with the news on the development of ultra-high resolution 4D image radar to compete with our competitors in the worldwide. This is a result of the innovation happened at the Siheung campus between the smart radar system and then SNU. And then this is to surprise to the industry that collaboration with a small startup can even drive the big companies' stock. So when it comes to the mobility industry, basically software is eating everything. So electronic orchestration and the software choreography in cars and the smart cities are happening. For example, in the automotive industry, the electronic system as a percent of a total car cost will reach 50% of the entire cost by 2020. That means the recent semiconductor shortage has placed an intense spotlight on the auto industry's reliance on the dozens of concealed computers embedded throughout the vehicles today. For example, BMW 7 may contain more than 150 issues or more, and then the pickup trucks like Ford F-150 may have more than 150 million lines of code. The same thing will happen in the smart city environment. As you see on the right-hand side of the slide, the smart city itself has a very complex architecture. So it is very important to have the seamless integration of sensors, devices, computers, and the software capability to build the entire smart city infrastructure. So this is a very crucial element in developing the true smart city. So when it comes to smart city, Siheung City is the leader in smart city. So this is a 10 innovative business model of a hyper smart city driven by SNU GRC, starting with the autonomous vehicle, smart industry complex, robotics logistics, followed by disaster management by drones, urban air mobility, hybrid digital twins, hyper data center and the my data, marine fund, biomedical cluster, and then finally there will be an innovation center and then human capital. So with these 10 business models and the innovations, radar will be the key kind of element to drive the success of these 10 business model. So in the next slide, we're gonna see how the radar plays in the smart city as a key infrastructure component. Now, let me talk about how radar plays as an essential sensor in building smart city. As you see in the left-hand side of the slide, smart radar system has a variety of products starting from the single radar, that's a simple radar, all the way to the very complex image radar systems. We utilize the Future Mobility Technical Center located in SNU Siheung campus to prove the capability of these radars. So as a result of that, we secured many customers starting from LG U+, and then major other companies in USA, Japan, and Korea as well. So with that, we are going after public security market, smart places, smart traffic, automotive industry, security drones, smart transportation, healthcare, and then lastly, but not the leastly, the smart factory industry as well. Now let me talk about how the 4D image radar can drive the autonomous vehicles. This is my favorite use case of the radar in autonomous driving. On your left-hand side, we have a 4D image radar. And we installed 5 of them in a Hyundai Ioniq, which is autonomous driving cars. Now let me play how these 5 radars collect data on a car to give data sets for the autonomous driving. For example, we ran the Hyundai Ioniq on the FMTC on the road, and then these are the data collected by the image radars. The different color means the height of the object, and then as you see, the radar collects data like LiDAR does. And then this is a case where we ran the car in the Gwana campus, and then as you see, we find many objects coming towards the vehicle, and then we also was able to identify the motorcycle and then the cars. And then this is another example of using the image radars to draw the driver map of the parking lot. So we are working closely with the autonomous driving players to enable their 360-degree parking view of the car, so that they can rely on the radar, not the camera, to have a safe parking system. So as you see, this is a big collaboration between Smart Radar System and then SNU in FMTC. So together with the VDCL, GRC, SRS, we are bringing the autonomous driving to the world. We also collect the data in the real world, not in the campus environment. And then, as you see in the picture, the white dots represent the point cloud collected by the radar, and the red dots are traditional point cloud collected by the LiDAR systems. As you see, they are matching together, and then with the image radar, we are able to identify the cars in front of the vehicle, also the cars passing through the vehicle as well. So with this kind of a successful field trial, we're going to expand that kind of system into the bus very soon, so that the bus may have 7 radar systems to have a 360-degree view. And then we will run both cars in the Sihung city to get the real field trial, so that eventually we're going to commercialize this radar system as an essential sensor for autonomous driving. As I mentioned in the beginning of this presentation, radar has many use cases in building the smart city. This is the case. Radar is used to create smart places, and then in case of a smart office, radar can be installed in the places like meeting room, office lounges, and then the toilets. So that any emergency situation happens, the radar will detect the situation and then let the personnel know that, so that they can have the fall down people. So when it comes to a smart home, there are many places, including bedrooms, study rooms, kitchen, door, and then living rooms, where you install the radar to detect the emergency situation. Again, the radar will let the personnel know so that they can help the people inside the home. So the image radar can save lives in the very dangerous situation. This is a case where we installed our radar in the kindergarten or in the school, elementary school, and then we marked the dangerous area as a red box. So if a small children goes there, then radar will detect it and then send the alarm message to the teacher, so that the teacher came in and then save the children. For example, let me play the video. In this video, the children was playing on the desk right next to the window, and then if he gets fall down, it's going to be very dangerous. So in that case, radar detected the small kid and then sent the alarm message to the teacher, and then sooner or later the teacher will receive the message, and then she come into the places and then save the children. So this is a case where the radar was very useful in detecting the dangerous situation. Besides the security or safety use cases of the smart radar system, there's one more very important use case of the image radar in case of hospitals, nursing homes, and the single family homes where the elderly people or the patients may fall down. The problem is how we're going to do the fall detection without violating the privacy. The camera may work. The problem is the privacy will be kind of violated. So we use the image radar to the fall detection, and that has been approved well, and then it's being adopted by many places, including the schools, hospitals, and then the factories as well. But you know what? What's more important is how we're going to predict if the person will fall down or not. So in order to do that, we are working closely with the hospitals for gait analysis. So you want to kind of analyze the behavior of the person and then how they walk in case of their nervous system goes down. So radar itself cannot give all the data. So we combine data from the IMU sensors or sometimes with the camera for the sensor fusion. So remaining thing is how we're going to run the AI algorithm on the fusion the data sets. At the bottom of the slide, we have use cases in the hospital where they want to decide if the person may fall down or not. So let me play the video. For example, there is a bed in the middle of the screen, and then we divide the bed into 3 sections. The bottom section, that's the place where the patient may go through when they try to come out of the bed. The problem of elderly people or the patient is that they think they can walk, but in reality, they may be in danger right after they come out of the bed. So the hospitals wants to detect the moment when the patients start leaving the bed. So we use the radar system, image radar, to analyze the behavior of the patient. And then in this case, the patient was lying down and then slowly crawling to the bottom of the bed, and then finally the patient exits the bed and then standing right next to the bed. So in this case, the hospitals want us to notify the nurses or the guardians so that they can come into the room and then start helping the patients. So as I mentioned, fall detection is very important, but what's more important is to detect the moment before the fall actually happens. So this is a very useful case of image radar in emergency situations. As a final use case of the radar in the smart city, let me talk about the smart pole systems. So in case of Korea, we have a smart poles where no matter where you go in the roadside. For example, the smart pole has a CCTV and then along with the signal. Nowadays, some of the smart pole has a Wi-Fi capabilities, including the LED lights, and then they do have an emergency panic button. So in case of an emergency, the person can touch the button, and then there will be a kind of a helper to come down and then help the people. And then with that, they are continuously adding other capabilities, including the IoT, autonomous driving, and the 5G capabilities to make this more like an infrastructure as a smarter city. But that today's smart pole technology is a kind of old technology. Now this is a time for us to scale up from the smart pole to something called the PIN. PIN means Public Infrastructure Network Node, and this is what's happening in the United States. For example, on your left-hand side, this is a traditional smart pole system. Now, when it comes to the Public Infrastructure Network Node, they will have a lot of sensors starting from radars, LiDARs, and the cameras, and then the 5G kind of a modem capabilities. They're followed by the edge computing with the high-end computers, and then on the bottom of the pole, there will be a battery system to drive the entire sensors. So this will be the new concept of the smart pole, and then this is being considered in the United States as a public infrastructure network node. Now, the people in the United States has a grand vision of bringing the new infrastructure. Let's talk about the infrastructure, history of the infrastructure in the United States. Starting from 1862, they put all the railroad system, followed by 1932, and then they laid out all the communication infrastructure. And then the last infrastructure they put was the internet, which happened in 1996. After that, for the last 25 years, there had been no infrastructure. And then they are thinking about putting a new infrastructure called autonomy. And then previously mentioned public infrastructure network node will be the key item for the infrastructure. So they want to put this kind of a pin and public infrastructure network node throughout the entire highway system so that any cars in the autonomous driving can be helped by this public infrastructure network node. So initially, they will have a pilot trial with many places, including the military camp, and then few cities, including the city of Austin in Texas. Here, they're going to put the pins very in dense mode so that anybody, including the car or people, any organization, they can have data from this public infrastructure network node. I like this kind of idea, and then I wish this kind of a new infrastructure is happening in the States very soon. So I've talked about the basic use case of radar in building the smart city, but we do not forget about what's happening in Siheung. So there is a big collaboration between smart radar system, the Seoul National University, and then Siheung Smart City. Our eventual goal is to bring any kind of innovation, including the autonomous ship and the drone taxi, into the reality in the Siheung area. So in order to make that happen, we are working very closely with the SNU, and then we are helping ITPP students to get up to the knowledge in the radar system. So for this semester, we actually worked with many students in ITT. So they came up with 3 concepts, including radar cam for the security in the small environment, and then another team came up with a security idea in the education sector where they use a radar to watch or monitor behavior of the small children so that if they are in dangerous situation, they're going to save that kind of children. And then lastly, I like this idea where they want to use a drone with a radar to detect people in the disastrous environment. For example, when the home or the building caught a fire, then if traditional camera may not work, so they want to use a radar attached on the drone to detect the people inside the home which is in danger. So these are the ideas created by the students working with a smart radar system, and then we're going to expand this kind of idea into real kind of a business cases working with them. So this is a collaboration between us and then SNU in Siheung campus. Again, thank you for listening to my presentation. And then this is time for everybody in the world to build a new infrastructure. And then we'd like to thank the infrastructure heroes, as Norman Anderson mentioned in his book. Thank you very much.